This is the review from the Unit 4 test, Systems of Equations and Inequalities. Okay, I'm going to start with number 1. The sum of two numbers is 450. 3 times the larger number is 1,350 minus 3 times the smaller number. Barry decides that the two numbers are 200 and 250 since his answer satisfies both equations. Is he correct? Why or why not? All right, so it's not enough just to plug these numbers in and see if he's right, because he could be right and that may not still be the answer, because we could have more than one solution be correct. So we also need to check to see if these are correct, but we need to find the solution to this system. And we're going to do that by, we've got two numbers, a larger number and a smaller number, so we're going to let x equal the larger number. And we'll let y equal the smaller number. And then we're going to write two equations because we have two variables. And so we'll get our first equation from the sum of two numbers is 450. So if we're going to do the sum, that would be x plus y equals 450. And then 3 times the larger number, and we said the larger number was x, so we're going to have 3x is, that means equals, 1,350 minus 3 times the smaller number, which is y, so 3y. All right, now there are several ways that we can solve this system. We want to find where these two lines intersect. And we can use one of four methods. We could use matrices, we could use graphing, elimination, or substitution. And I'm going to go ahead and use matrices on this one. And in order to do that, they need to be in standard form. This one is already x, then y, then equals a number. So I need x, then y, then equals a number. So I'm going to add 3y to both sides. So I'm going to have 3x plus 3y equals 1,350. And then that will cancel out right there. And now I have it in the standard form that I need it. So I'm going to put this one in my matrix and this one in my matrix. Okay, so I'm going to do second matrix, edit. And this is a 2 by 3 because there are 2 rows and 3 columns. Okay, so 2 by 3. Then I'll enter 1, 1, 450, and then 3, 3, 1350. Okay, and then from there, we're going to do second quit, and then second matrix again, over to math. I'm going to go up to RREF, and then second matrix again, and I'm going to place matrix A, the one that I worked on, in there, and I get this matrix. And notice that it's not diagonal ones, and what we have on the bottom is 0, 0, 0, which is no solution or infinite solutions. It's infinite solutions because you can say that 0 plus 0 equals 0 here. Okay? So anytime you get 0 straight across the bottom, that is infinite solutions. So what that means is that Barry's solutions are correct, but there are more than just his solutions. There are an infinite number of solutions. Okay, so what we're going to write here is that Barry's numbers work, but there are infinite solutions. So he was partially correct. All right, then number 2. If 3, 0 is the unique solution to a system of linear equations, then the graph of the system would show which of the following. And what we mean by unique is that it is the one and only solution. All right, so the two identical lines, that would mean infinite solutions. You would have more than one solution. 2 parallel lines means no solution because they never cross, they never intersect. Identical lines intersect everywhere. That's why there's infinite solutions. At least one vertical line has nothing to do with systems. Just because it's a vertical line does not mean anything. Then two intersecting lines. That is the one we want, because two lines that intersect have exactly one unique solution. So J would be the answer to this one. Okay, number 3. If you were solving for the number of buses and vans to charter for the senior class trip, what type of answers would not be reasonable? In other words, we can't have negative vans or buses, so we're going to have negative numbers, would not be reasonable. Other numbers that would not be reasonable would be decimals or fractions, because you can't have half a bus or a third of a bus. So what would be reasonable would be positive whole numbers, like 0. We could have 0, 1, 2, 3, etc. Okay, number 4. Which of the following system of inequality describes the graph below? So this is a kind of graph where they give you the graph and you have to write the inequalities that go with this graph. So we're going to start with a dotted line, and we're going to write a line for this dotted line. And notice that the y-intercept is at -1, and the slope, it goes up 1 over 1. So we can say y, and instead of putting equals to, we're going to either put less than or greater than. We'll do that in a minute. And we'll have, for the y-intercept, -1. And then up 1 over 1 would be 1 over 1x, or just 1x. Okay, then it is shaded above it, which means we would use greater than. It's a dotted line, so we won't have an equals to. Okay. Now we can look here, and already look, are any of these like this? Well, the first one's almost like that, but it's got an equals to, so it can't be that one. This one is less than, and it's not shaded below. It's shaded above it, so it can't be that one. This one looks good. This one does not look right, so it's probably H, but we're going to check this one just to be sure. Let's look at this line right here. It crosses at 4, and it goes down 2 over 1, it looks like. Let's pick another point here. Down 2 over 1, down 2 over 1, down 2 over 1. So that would be a -2 over 1, which just is a -2x. We have a -2x plus 4. And then this one is shaded down from it, so it is less than. It has a solid line, so it has an equals to. Now there's not one that really looks like that, except that's not 4, is it? 1, 2, 3, 4, 5. That's a 5. All right, we're going to see if this and this are the same. So if we add 2x to both sides, then I get 2x plus y is less than or equal to 5. And that one does match that, so it's got to be H. Okay, number 5. The school jazz ensemble collected $1,470 for 240 tickets sold for their concert. If adult tickets were $8 each and student tickets were $5 each, how many of each were sold? Set up equations and solve. Okay, so we need some variables. We're going to say let A equal the number of adult tickets and we'll let S equal the number of student tickets. Okay, then we'll write two equations because we have two variables. And it says the school jazz ensemble collected $1,470 for 240 tickets sold for their concert. So we're always going to look for a total number. In this case, a total number of tickets sold was 240. So we could say that A plus S equals 240. The number of adult tickets plus the number of student tickets would equal the total number of tickets. Okay, and then we have a total account for how much money they collected. And since adult tickets were $8 each, we can write 8A plus student tickets are $5 each. $5 times the number of student tickets equals $1,470. Now we need to solve it, and we can solve it using elimination, substitution, graphing, or matrices. This time I think I'm going to solve it. I'm going to go ahead and solve it using matrices. I think it's probably the best one for making it. It's probably the least mistakes will be made with this one, but you could use elimination and multiply everything by -5 or -8. Okay, so, but I'm going to go ahead and do matrices. So I'm going to do second matrix, edit, and it's still a 2 by 3. There's 2 rows, 3 columns. So in here I'm going to put 1, 1, oh, it's a 2 by 3. 2, 3, and then 1, 1, 240, and then 8, 5, 1,470. And then we'll do second quick, second matrix, over to math, up to RREF, second matrix, enter, and we get diagonal ones, so it looks like we probably did it right with some whole number tickets. That's good. So since A is our first one that we listed, then A is 90 and S is 150. Does that mean A is 90 adult tickets sold? Okay, let me see if I can spell tickets. Here we go. And S is 150 tickets. Now just to check it, this would be student tickets. Let's at least make sure that 90 plus 150 is 240. So 90 plus 150 is 240. Then you could also plug it in here. 8 times 90 plus 5 times 150, and that should give us 1,470, and it does. Okay. All right, number 6, set up a system of equations to solve the following, but do not solve. So we're just setting this one up. A total of 570 tickets were sold for an event. 4 times as many adult tickets, A, were sold as children's tickets, C. The total number of adult and children's tickets sold was 1/2 the number of student tickets sold, S. All right, so we have A, C, and S. We have 3 variables here. So A is going to equal number of adult tickets. C is going to equal number of children's tickets. And S is going to equal the number of student tickets. Okay, and there's probably a total where we do A plus C plus S, and it does say that a total of 570 tickets were sold. So that's the first one we'll write. A plus C plus S equals 570. And then we need 2 more equations because we've got 3 variables this time. So we need 3 equations total. So we've got 4 times as many adult tickets were sold as children's tickets. So you ask yourself, which was sold more, the adult tickets or children's tickets? And it says adult tickets were more, so adult tickets will equal 4 times the children's tickets. 4 times as many adult tickets were sold as children. Okay, then our next one will be the total number of adult and children's tickets sold was 1/2. So let's do that. The total number of adult and children, so A plus C, total means to add, was, that equals 1/2 the number of student tickets. So it'll be 1/2 S. And it said, do not solve. So this is all we have to do right here. That is our answer.